Hey, this is Steven from LegitPC and welcome back to my product design series. So we are back working on the plasma table, CNC plasma table. This is video number 3. And so last video we kind of decided on the 2.5 by 2.5 size beam for the arms and the legs. Oh, that's not good. So we decided on about 2.5 by 2.5 by 1/8 inch wall. Unfortunately, I was going to call, I forgot to call Sims earlier to ask them if they had that. So that was, they closed at 12 and now it's 12:13. So no longer open. So I'm saying somewhere around 2.5 by 2.5 for a decent size plate. Go up to 1/2 inch. So this one in millimeters is okay, and if anything we could just add some more to the structure where we have it come up here and then mount, have like a truss thing to hold it up in the middle so it doesn't bow there. That should be fine. So even with 2 inch, I think 2 inch would probably be even okay. And then if we had to add more, we could add more to where it doesn't bow. So maybe even 2 inch to have it nice and lightweight, easy to carry. Why is it doing this? Oops. Easier to install. So maybe 2 inches. 2 inches is pretty small. 2 inches is about like this. Apparently it says that it's okay. Let's try this again. I wonder if it doesn't like me recording it. Yeah, this is 1.5 thou. I mean, it's gonna, I think this will be okay. And then this, for how much load is this? This is 81 pounds. So this is a normal load, I believe. This is a 1/4 inch for this section. And obviously half here, half over there. I think probably split the difference of 2.5. Because this is 12-pound mass. Do not close. Do not close. Okay. And then this is 16-pound mass. So it's 15. So yeah, the other one is 160 pounds. This is about 200 pounds. I think 2.5 should be okay. So we'll run with 2.5 right now, and then if not, we might change to 2 inches. But 2 inches, it's 12 pounds. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's about 120 pounds. The other one's about 200 pounds. So yeah, let's go with 2.5 right now. And also, obviously, the 2.5 is going to be more expensive to run than the 2 inches. By how much is probably by pound. Maybe with the deal I get, it might be 100, maybe $100 for this one, maybe $80 for this one total, to build all those steel of the frame at least. I don't know about the slats. Slats is a different deal. Okay, so let's go ahead and start setting up the file structure here. So we have a layout, and then we'll have all our parts in here as normal. Layout, and then what are some of the other ones we could have? Assemblies. So I'll call these like sub-assemblies, new folder sub-assemblies. So that's where we're going to have like smaller layouts. For example, the gantry itself, have that laid out so that when we bring it into the main layout, we could have it update from the sub-assembly. Okay, let's do 2.5 for right now. Okay, so let's create a new design. This one is going to be called main. This is going to be a main assembly. Should probably also call this assembly, so I just generally call them layouts. Okay, let's go ahead and drag this in. Okay. So another question that we have is this going to be a continuous piece, 8 feet long, or a smaller piece like this, 4 feet long? I'm thinking more of the 8 feet long. The main problem that I have is whether these will be bent or not. I know that Sims for sure sells at 8 feet long, so maybe we'll create an 8 foot long. It says file save as by 8 feet. Okay, so and then this one's going to be the 4 foot. So we are going to use this one. We're going to use 2 of these. Also, we need to edit this so it's 8 feet long. And these 4 feet. So let's go ahead and save this. Oops. Go back to the main assembly. 1. Copy, paste, move it over. Copy, paste. Oops. Say OK. Copy, paste. Move it over. Sorry, I only need 2 of these, 2 of these. Okay, so now what we're going to do is we're going to go to the top and let's go ahead and rotate these so that these are flat, so that we are looking at the right views are the right views. So let's go ahead and rotate these. Rotate. Looks like we have one extra still in there. This one, move. Rotate. Okay. Also, another thing is that these are probably going to have to actually be longer depending on how we have these lapped. So if we have these lapped how I think we're going to have them lapped, we need at least 2.5 inches on each side. So what I'm going to suggest is go to this one. I think this is, no, so this is no longer the one that we have. We're going to do 2.5 by 2.5 by this one. Bring that one up, go into model, and then we need to have these. I'll show you guys what I'm talking about here in a second. Because we could just worry about that. That's why we assemble things digitally first, which I'll show you guys how I expect to lap them. Capture position. So here on one, and then here on the other one, which is going to be here on this bottom corner. Okay, alright, you want to go that way? That's fine. Okay, so then here on this inside corner, then here on this inside corner. There you go. So there's half the frame, and then from here, this inside corner. Oops. This inside corner. rotated 90 degrees to 70 degrees. There you go. Uh-oh. What? Oh. Yeah, see, I did it slightly differently. This is supposed to be, I guess I could do that, technically. But then that would mean that this other one needs to be longer, instead of these ones being longer. So how do I want to do that? So yeah, let's modify this. Let's go ahead and delete this joint. This joint, let's edit. Okay, so this one is going to have something. So what I wanted it to do is that these are outside, like this bottom corner, and somewhere over here like that. And that's not quite right. Minus 2.5 inches. Nice. There you go. Like that. And probably what I'll also do is I'll probably also put a scab across there so it grabs on all sides instead of just on the skin of that thing. Put a scab there. And then here, because also I have an 8-foot bed in my truck, so so I don't want it to be longer. And also I won't have to hold as long of a piece because these are definitely going to be shorter. So I'll show you guys what I'm talking about here in a second, why one of these has to be longer. Okay. Oh, that's a short piece. The long piece. There we go. Yeah, it matters whether that thing turns white or not. So last joint. That side here. Okay, so now there's the start of our frame. So now when I measure it from here to here, distance of 43 inches, which is 4 feet is 48 inches. So it's minus 2.5 here and 2.5 here. So that being said, we need to go back here, and these, in order to be long enough, have to be, which I'm going to have at least ½ an inch on each side, because mainly the problem with the travel. So this guy is definitely going to have to be, I'm going to say maybe 10 feet. let's say 9 feet. Let's try 9 feet. So let's edit this to 9 feet. 9 feet, 9 feet. Save it. Go back to main assembly. Update. There you go, 9 feet. So now what's the distance from here to here? This is length 48 inches. Wait, what? Oh, 108, which is 108 inches. Let's turn this into feet. Document type, inches, feet, foot. So it's a little bit easier to see these distances. This is 9 feet, so that's an extra foot. Well, there to there should be perfectly 9 feet. So here, maybe have half a foot, 6 inch extra that I could go back and forth, so 3 inches. So let's turn this one into 8.5 feet. Oops. Whoops. Let's save this one. Update this. So now, with this way, so this ways are obviously 8.5 feet. Oops. 8.5. So now what about from here to here? See, this is 3.5 feet. So let's add another foot to that. So let's go here, edit the top here. So now this is 5 feet. There you go. There you go. 4.5 and plus a little bit feet. Alright, so there's our table. Total weight is properties. Total weight is 109 pounds. Just those pieces. Alright then, how tall do I want? I'm about 6 feet tall. I'm cool if it's maybe up to about midsection level, so maybe half my height. So let's say maybe 3 feet off the ground or so. So let's have this one, this file save as, let's say this is a leg. Let's say this is 3 feet. I don't know which one this is. Which one of these? I think it's this one. No. No, it's gotta be this one. Yeah. So there's a leg. What the hell? Oh, it's the other way, okay. Back left corner. Or back right corner, or whatever. Also put a scab across there. Then this is basically going to weld onto the scab. So there's going to be a scab plate down there. That's going to weld onto the scab. Okay. Now we need some in the middle. So what I'm going to do here, it should give me a middle section actually, now that I think about it. So I should be able to just do joint, hover somewhere. Oh, I can't hover in the middle. Oh, but I can hover on the outside corner. Okay. So it should give me the outside corner. Oops. Like so. I think I picked the wrong side, whatever. This is minus 2.5 inches. This one, same thing. Now pick the right side. And there we go. Okay. Now, let's don't show the joints, save the assembly, let's go into simulation, use static stress, and let's go ahead and run some constraints. Actually, first thing we're going to do is run some automatic contacts. Oops. DOFU, DOFU. Red is free, that's not good. Why is it free? Okay, also now we should be able to do weights or whatever, but 2. Then also another thing we're going to have is these in buckling. I think these will be okay in buckling. Buckling generally fails stuff pretty easily. Buckling and torsion way more than bending. Regular bending in the middle. Let's go ahead and do that. And then let's do a weight calculator. Steel, 836, flat, plate, number of pieces 1, gauge 0.5 inches or so, maximum width 48, length 9 times 12, that's 108. Calculate. 733 pounds. Okay. Everything's good. Everything's green. Ready to go. Solve locally. Solve. Alright. Actual deformation. Safety factor 15. It's good. Result stress. Stress is located in the joints. Yeah, right at the displacement. Ooh, that's high. It's 4/1000 of an inch right there. Base. Contact pressure and PSI. Set the junctions. Pound force, 19 pounds per leg. That doesn't sound right. Nineteen times 6. It's not 700. But again, this is a worst case scenario for this small little for this piece here. Ooh, not micron. So it's 4/1000 of an inch. So see, most of the stress is in these two places. So again, if I wanted to ever add any more, I could have some tubes come up from here and go up and then down, and cut some miters in them, and have them go like that to miter and come up and help these a little bit. Stress 1600 psi, minimum 1 psi. So I think this this will definitely take. So one last one before we go off. Let's try 1 inch thick plate steel 836, which is 1467072. Just go ahead and run this, and then we'll stop the video there. We should maybe see a this one we might see a safety factor of like 6 or so. Oh. Let's just change one of these to 0.1. Let's do on cloud. So now it's on cloud. We could even do some other stuff. So yeah, I think this frame is definitely good enough how I have it set up, just simple here. And then the rails are going to ride on top here. So we have like some tubular structure that would ride on top here, ride all the way up to this point. And then with the belts, we would have a belt attach point here where we just drill a hole and put the belt in there. And then here also drill belt. And so we have as small length of belt as possible, which is 8 feet is the smallest we get. Obviously it needs to be a little bit longer than that in order for it to go up and over the gantry to get on there. So we're probably going to use like the old school gantry style where it has the where it has the 2 belts. It has 2 pulleys. It goes up and over the belt. It goes up and over the. It has 2 bearings. It goes under the bearing, up, over the pulley, down, and back under the bearing, and then it is tightened down to these pieces here to keep it from slipping. It's fastened to the edges here. So 1, 2, 3, 4 positions. Goes up and over the belt, and then we have another one that goes across, and that sits on top of that gantry. And this way we have very little weight still. Let's see what our actual weight is here. It's in kilograms. Mm, 181 pounds. So with that last piece, we're probably looking at, we got 200 pounds. Should be easy for 2 people to lift this up and bring it inside. Be able to haul it around. Okay, so we have an actual minimum safety factor of 10 now. So let's see where the safety factor is there. Stress. Okay, we have definitely getting up in the PSI, 3.3 thousand PSI. And what are we getting for displacement? Displacement maximum, in inches is 8 thou. I'm fine with that. For maximum of a 1 inch plate. Alright, so I'm happy with this. Maybe we could even drop it down to a 2 inch tube. But we'll run 2.5 for right now, just just to be safe. Alright, so this has been Steven from LegitTechTutorials. I'd like to thank you guys for watching. If you liked this video, please subscribe for more videos like in this series and other series as well. I'll see you guys in the next video. Thanks for watching. Take it easy. Peace.